Hello, Math 2 students. Today I'm going to go through the notes for 7.2 Day 3. It's angles and arcs all mixed up. Alright, so there's going to be a lot of formulas that we see during this video. And I would definitely recommend having a highlight, or I would say 2 highlighters if you can. I think it'll help with labeling things within your notes. So let's go ahead and get started, alright? So, basically, if we look at this image here, all right, what we have is we have 2 tangent lines, all right? You can see that they hit the circle at one point, and those 2 tangent lines make a angle on the exterior of the circle. So we can look, the vertex of that angle is on the exterior, all right? And we would classify this as tangent, because there's 2 tangent lines forming that angle. And the formula that we're going to use for this is, let's see, I'll use, what 2 colors should I use? We'll do red and blue. All right, so we will, I wanted highlighter. There we go. All right, so on the outside here, we have arc ABC, okay? And then on the inside, we have arc AC, okay? So to find the value of x, what we're going to do is we are going to put 1/2, and it's going to be arc ABC. All right, so we take that big red arc, and then we subtract it from arc AC. All right? And another equation we could use here would be x plus arc AC is equal to 180. That is another equation you can use here. All right, next, if we look here, this we've actually seen before. This is we've talked about this. This is called the central angle. And you can see here that the vertex of the angle is at the center of the circle. All right, so our vertex is at the center. All right, and we would call this a central angle. And if we look here, arc AB is equal to x, and we learned that, right? We learned that within a central angle, the intercepted arc is equal to the angle. So that's going to be equal to arc AB. All right. So next, we have this here. All right. Now, if we look, this is what we learned as an inscribed angle. So that's actually the name of this. We're doing purple. All right, and if you look at where the vertex of an inscribed angle is, it's on the circle, okay? Different than at the center, and we know that the inscribed angle is 1/2 the intercepted arc, all right? So we know that 1/2 arc AC would be equal, or AB, don't know why I did C. AB would be equal to the angle. Next, all right, we have an angle here that's actually going to be formed by 2 chords. Do you see how these 2 chords make up the angle? It's different than this because these guys are tangent. You can see that these guys don't go through 2 points on the circle. They just go through 1 on the edge of the circle there. The chords cut through the circle, right? We learned what a chord is, right? It goes from one end to the other, but doesn't go through the middle. And so the angle here, the x value, is outside of the circle. All right, it's on the exterior. And we would call this a secant. All right, And what we're going to do, let me start off with the red first, is we're going to take arc AB, all right, subtract it from arc CD, and then multiply it by 1/2. So the formula is 1/2 AB minus CD. All right, so basically you get this angle by doing this guy minus this guy divided by 2 or multiply it by 1/2. All right. All right, next one. We have two chords that intersect inside of the circle forming an angle. All right, so where is that angle at? It is inside the circle. But not at the center. All right, and we call this a chord. And to find the measure of angle X, okay, we are going to go ahead and do AB and take CD. And this one's a little bit different. Instead of subtracting, a lot of these, right, have been the difference so far. This one we're actually going to add. So it's going to be 1/2. And then we're going to do arc AB plus arc CD. All right, and that will give us our X value. Now, I'm sure you're kind of like, oh my gosh, these are so many formulas. Just relax. We're going to, do a lot of example problems. And you'll see, once you kind of start using these in context, it won't be as overwhelming. All right, next one. We have an angle that is on the circle. This is another inscribed angle they're showing us here. So we can see we've got arc AB here. And just like we learned before, oops, can't find the right color. The angle here is on the circle. And this would be an inscribed angle. Oops. All right, and the formula is going to be 1/2 the arc length. So 1/2 arc AB. That's something we already know. All right, so now this one's tricky, okay? Again, we have our angle on the outside of the circle. All right, on the exterior. And this one, though, it's formed by the two lines that form it. We have one tangent line and one secant line. The secant line goes through it at 2 points. All right. So let's go ahead and label our sides here. We've got our big arc ABC, and then our little arc, in this case, is going to be AD. All right, and, oh, I forgot to write this down. Tangent, secant, and then the formula is 1/2. And then we're going to do our arc ABC minus arc AD. All right, okay, let's go ahead and kind of see what work we can do here, okay? So if we look, they want us to find X here. So we have to go back and look at our chart. If we look at where X is, it's on the inside of the circle, but it actually is the vertex is on the circle. All right, so if we look back at these examples, you can see that it actually is an inscribed angle here. All right, and we know that with an inscribed angle, it's 1/2 the value of the arc. So if we look, first off, let's put down that we have an, oh my gosh. We have an inscribed angle, and we know that to find X, we need to do 1/2 of our 1/2 of our arc to find our angle. So we're going to do 1/2 of 70, and we should get 35 degrees. All right. Now here we're doing the opposite. okay? It's also an inscribed angle. If we look, right, we have our vertex on the circle. We have our intercepted arc here. However, we're doing the opposite. We know that our x value, this is actually kind of now our x, right? We would say that 50, if we do 1/2 of the arc here, right, we can go ahead, multiply both sides, we get 100. Honestly, easier way to think about it is just to go from the inscribed angle to the intercepted arc, you just double it, right? If you're going from the arc to the angle, you half it. If you're going from the angle to the arc, you double it, okay? Now, this guy here is another tricky one. We've got secant, secant. If we look here, we've got those two chords that are going through that touch the circle twice, all right? And then they have the angle on the exterior of the circle. So the formula, I guess I should have looked at the formula before I scrolled away. So the formula here, maybe I'll actually copy paste that, is we're going to do the bigger arc, paste. We're going to do 1/2 of this guy minus this guy. And if you look at the image, you can see where that's all coming from. And also this x should be right here. That was just a typo. So we've got 1/2, and then our bigger guy there is our 90 minus 70. We end up with 1/2 of 20, which gives us 10. All right. So x is 10 degrees. All right. This one's basically the same exact thing. Okay. However, they gave us x. They gave us, I should say, instead of saying they gave us x, they gave us our angle. And now we have to find one of the arcs here. Okay. So we're going to have to do this guy minus this guy times 1/2 equals 40. All right. So we do our angle equals 1/2 times our x minus 25. That's us just filling into this formula here. And we have to go ahead and solve, all right? So you could distribute and solve from there if you want to distribute. But I'm going to make life a little bit easier. I'm going to multiply both sides by 2 and cancel out my 1/2. And then I get 80 equals x minus 25. I add 25 to both sides, and I get that x is going to be 105. All right. Okay, we're doing good, my friends. We're almost there. All right, next one we have here. This one, we've got a tangent line and a tangent line forming an angle on the outside of the circle. So this guy is going to fall under tangent, tangent. All right. So if we look at tangent, tangent, they actually gave us 2 formulas for that. Let me copy. Oh, no, I don't want to cut it. All right. So one is that we can do the big guy minus the small guy divided by 2, right, or times 1/2. However, if we look, we don't know what this guy is. We have no idea. So we could use this other formula. Basically, it's that our angle plus the smaller arc have to equal 180. So it's just going to be x plus 42 equals 180. We subtract 42 from both sides, and we get 138. All right. All right. Let's go ahead. This one is an interesting one. All right. This one is going to fall under tangent, secant. Okay. I don't know why I'm writing so bad. T-A-N. All right. And if we look at the tangent secant, all right, we know that it's the big guy minus the small guy divided by, or times 1/2. Okay. So basically, we need to do this guy, the red guy minus the blue guy times 1/2. However, the problem is we don't know what the blue guy is. right? However, this secant line is a special secant line. Do you see how it goes through the center? This actually is the diameter, right? And the diameter is going to cut the circle in half. Half of the measure of a circle is 180. So if this is 110, this guy here has to be 70. All right? So we can go ahead and plug that right into our formula. We're going to do 110 minus 70 times 1/2. We get 1/2 times 40, which is going to give us 20 degrees as our x value. All right, we are almost there, my friends. Let's go ahead and try this one. All right, if we look, this one's going to fall under chord, right? So let's go ahead, let's steal the formula. Steal the secret formula. All right, we'll put that down here. All right, and we're trying to find x here, right? And we've got one of our arcs here and the other arc here. So what we need to do is we need to do 1/2, and notice we're adding these. We're going to do 100 plus 80. We get 1/2, 100, or 1/2, 180. And I get 90 degrees. All right, not too shabby. Now, if we look, we have our two arcs. We've got this guy. We've got this guy. And we know that our angle is going to have to equal 1/2 the sum of that. So we're going to say 105 is equal to 1/2 x plus 100. Now again, we could distribute if you like, but let's make life easier. We can multiply both sides by 2. We get 210 equals x plus 100. We subtract that 100 from both sides, and we get 110 equals x, and that's our answer. All right, thanks for bearing with me here, friends. We'll definitely do some more practice in class tomorrow.